In this video, we will learn how to answer questions like this. Given vector u, which equals 3, 4, how do you find a vector with the same direction but a magnitude of 7? Now, frankly, the problems we've been doing so far have seemed a little bit easy, and we've done them over and over again. But out of nowhere, we run into this question, which just might blow your mind! So bear with me. So first of all, let's get a few things straight. Vector u with components 3, 4. Imagine that if this is the initial point, it goes right 3 and up 4. So it would be like this. Okay, horizontal component 3 and then up 4 for the vertical component. So the actual vector u would look like this. Alright, and if you were to do the Pythagorean theorem, you would quickly find that the magnitude is 5. So the magnitude of vector u is 5. Keep that in the back of your mind. Now, the first thing you need to remember is what happens when we multiply by a scalar. So, for example, say if I were to take this vector u, which is 3, 4. All right, and what if I were to multiply vector u by the number 2? So what if I did 2 times vector u? Well, that would be 2 times this, so that would give me 6, 8. So what would happen? So now this would be 6, all right, it would be twice as long. This would be 8. It would be twice as long, and then our new vector 2u would be like this. It would be twice as long, and it would, it would be 10. But look what's happening. Our new vector, okay, this pink vector is the vector 2u. It's twice as long, but did the direction change? No. The direction is exactly the same as the original vector. So, hold this in your mind. Remember that multiplying by a scalar changes the length of the vector, but it does not affect the direction. Alright? That's important because since we want to have the same direction and just with a new magnitude, it's good to know that multiplying by a scalar will not change the direction. So if we just stick to multiplying by a scalar, we don't have to worry about the direction. We're going to solve this problem in 2 steps. So step 1 is to divide by the old magnitude to form a unit vector. In other words, a vector that has magnitude 1. So the original magnitude is 5. So if I divide by 5, then I should have a magnitude of 1. The way that we divide by 5 is multiplying by 1/5. So if I take the original vector of 3, 4 and multiply by 1/5, I'm really dividing by 5. So again, the magnitude was 5. I'm dividing by 5, so that's going to create a vector of magnitude 1. This is going to make a new vector 3/5, 4/5. Now this vector, like just side note, this vector has a magnitude of 1. This is a unit vector. So remember vector u with the components right 3 up 4, magnitude of 5. So what we've just done, if I were to draw this new vector, this is now a vector in the same direction that has a magnitude of 1. So we've just created a little tiny vector that's in the exact same direction, but it has a magnitude of 1. Fun fact, a vector that's in the same direction as u, except it has a magnitude of 1, is written like this. You write U, but you put a little hat over it to show that it's the same direction as U, but the little hat means it's a unit vector magnitude 1. Okay, so that's it for step 1. Now step 2 is just to multiply by the new magnitude. Remember, right now we have magnitude 1. If you take something with a magnitude of 1, anything you multiply by, that's going to be the new magnitude. So if you have a magnitude of 1 and you multiply by 6, well, now you have a magnitude of 6. If you multiply by 7, well, now you have a magnitude of 7. So let's take our vector that has, let's take our unit vector, which has a magnitude of 1. And we're going to multiply it by the magnitude that we want. So in this case, we want a magnitude of 7. So all we have to do is multiply by 7, and we'll be done. Now remember, this is like 7 over 1. So I'm just going to multiply the numerators. So my new vector will be 21 over 5 and 28 over 5. And that's it. So we've taken the unit vector, shown here in blue, and now we've multiplied it by 7. So remember, the golden rule here is multiplying by a scalar does not change the direction. All we've done this entire time is multiply by a scalar. So taking this little unit vector and multiplying it by 7 is just making it 7 times as long in the same direction. So now we have a new vector that has magnitude 7 that's in the same direction, and that's what this is. Now just for fun, let's check the magnitude and see if it really is 7. Okay, so we know that if we want to calculate the magnitude, we would do the square root of, so that's the same thing as the square root of 441 over 25 plus 784 over 25. Alright, these have like denominators, so there's no reason why I can't add them together. 441 plus 784, that is 1,225. And we'll keep that common denominator. Now 25 divides evenly into 1,225 49 times. And the square root of 49 is 7. So, as a matter of fact, this vector that we found does have a magnitude of 7, and since all we did was multiply by scalars from the very beginning, it has the same direction as the original vector. So this definitely is the solution to the problem. Now example 5 is the same sort of problem. We want to find vector v in component form with the given magnitude, 7, and the same direction as vector u. So we want a vector that has the same direction as u, but with a magnitude 7. So it's almost like the problem that we just did. In fact, I encourage you to pause the video and try to do the problem by yourself first. Now, remember, this problem has 2 steps to it. So step 1, we're going to divide by the old magnitude. The goal is to make a unit vector in the same direction. That's why we'll divide by the original magnitude. But that reminds me, we don't know the old magnitude yet. So let's take a moment and calculate the magnitude of the original vector u. So that should be the square root of -2 squared plus -5 squared, which is going to equal the square root of 4 plus 25, which equals the square root of 29. So this is the original magnitude, the old magnitude. So we're going to divide by the old magnitude in order to get ourselves a unit vector. So we're going to take the original vector, -2, -5, and the way we can divide by radical 29 is to multiply by 1 over radical 29. Once we've done this, we will have ourselves a unit vector in the same direction. So remembering that this is really like having -2 over 1 and -5 over 1, I'm just multiplying straight across, and that's going to give me -2 over root 29, comma, -5 over root 29. Okay, so what we have here is a unit vector in the same direction. So this thing right here has magnitude equal to 1. Alright, now it's time for step 2. Step 2 is to multiply by the new magnitude. If you take something that has a magnitude of 1, if I multiply it by 2, then I'll have a magnitude of 2. If I multiply by 3, I'll have a magnitude of 3. In this case, I want a magnitude of 7, so I'm going to multiply by 7. So I'm going to take this unit vector and multiply by 7 for step 2. So I'm going to do 7 times my unit vector. Now, remembering that this is like having 7 over 1, and I'm multiplying straight across, so this 7 is really going to wind up only multiplying the numerators. So that's going to give me -14 over radical 29 and -35 over radical 29. Okay, so we had a vector that was magnitude 1. Then we multiplied by 7. So guess what? Now we have a vector that is magnitude 7. And because all we did was multiply by scalars, the direction has not changed. Alright, in step 1 we multiplied by a scalar, so this has the same direction. Then I multiplied by another scalar of 7. Still did not change the direction. So this is the answer to the question. Alright, this is the vector that has the same direction as the original vector, but magnitude equals 7. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.